Hi everyone, welcome to the Chemical Engineering Process Design Learning videos with Aspen Plus software. This is our fifth video lesson. This video lesson provides you knowledge and skills on how to simulate Continuous Stirred Tank Reactor CSTR and Plug Flow Reactor PFR in Aspen Plus. Let's consider the homogeneous liquid phase reaction of cis-to-trans isomerization of 2-butene. The first order reaction is carried out in a CSTR and PFR separately, where the volumetric flow rate is constant. Let's take feed mole rate of cis-2-butene is 1 kmol per hour into each reactor. The rate constant simple K has been experimentally found to be 0.23 per minute. We need to determine the conversion of each reactor at 10 minutes residence time. Let's open Aspen Plus software. Click New and create a blank simulation. Enter the all components in our system. We have only two components, cis-2-butene and trans-2-butene. After entering all the components, click Next button. Select NRTL as thermodynamic property method, which is valid for our system. After that, click Next button again and run the property analysis. Then go to simulation environment. We will draw the Aspen flow sheet using a duplicator block so that we can compare both CSTR and PFR within the same simulation. Draw the streams and name them properly. Place a CSTR and R plug equipment models in the flow sheet. Name them in proper names for easy identification. Draw the streams and name them properly. After the flow sheet is complete, click Next button. Enter the feed stream data as 25 degrees Celsius temperature, 1 atm pressure, and cis-2-butene mole flow rate as 1 kilomole per hour. Then click Next button. CSTR block setup will be open. Enter the temperature as 25 degrees Celsius and pressure as 1 atm. Select the valid phases as liquid only. Select the specification type as residence time and enter the residence time as 10 minutes. To enter the reactions, go to the Reactions tab in Navigation pane and click New. Select Reaction Type. In R1 Configuration tab, click New, which will open the stoichiometry window. Select reactants and products for this reaction. Then enter the stoichiometric coefficients and enter 1 for cis-2-butene reactant exponent, which marks up the order of the rate law expression. Thereafter, click on the Kinetics tab. In Kinetics tab, we can model the Arrhenius equation for rate law expression. In Aspen simulation, kinetic factor must be entered in SI units every time. Enter the activation energy as 0 so that our rate law expression can be modeled. Go back to CSTR block setup, Reactions tab, and select the available reaction set R1 for CSTR. Then go to PFR block setup and select reactor with specified temperature as reactor type with 25 degrees Celsius constant at specified reactor temperature. Then click Configuration tab and enter length as 2 meter and diameter as 0.3 meter as initial guess of geometry of our tubular reactor, which will be iterated to find solutions. Select liquid only for valid phases and select R1 reaction set for PFR in the Reactions tab. We need to create a design specification to specify the residence time parameter as 10 minutes. Design spec in Aspen Plus are used to manipulate input variables to achieve a desired operating result. Go to Flowsheeting options in navigation pane and select Design Spec. Then click New. A design specification with a default name DS1 will be created. In the Define tab, click New and create the variable as residence time. Click on Spec tab and enter the specification. Spec is equal to residence time. In the exact characters you define the specification. So we enter rest time, target as 10 minutes and tolerance as 0.001. Then click on Vary tab and specify the reactor length to be the manipulated variable because we initially entered an estimated guessing value for reactor length. Now all the input data have been entered properly for this simulation. Click Next and run the simulation. The simulation completes with no warnings and errors. To check the results for conversion, go to the main flow sheet and right-click on the product streams of each reactor. Click Analysis, then select Composition and check Mole, then click Go. The mole fraction of trans-2-butene in the product stream, which represents the conversion, is 0.6969 for CSTR. And the mole fraction of trans-2-butene in product stream for PFR is 0.8997. The results of the analytical solutions which were calculated manually are 0.6969 for CSTR, and the analytical solution for conversion of PFR is 0.8997, so that we can conclude the simulation results are identical to analytical solutions obtained from manual calculations. Next, we will simulate these reactors to find out the relationship between the volume and conversion. Before that, when we check the simulation results in Aspen Plus, we can see that cis-butene in the feed of each reactor, it shows a vapor fraction. So go back to feed in streams tab and go to flash options, then select liquid only as the valid phase. Then go back to results in CSTR so that we can see the volume of CSTR is shown in simulation results. The volume of the reactor at this state is nearly 15 liters. To have volume conversion relationship, go to CSTR setup again. Earlier we simulated using residence time as the specification type. This time we change it to be reactor volume. For iterations for our graph, we can enter the initial volume as 50 liters. We can generate two-axis graphs in Aspen Plus using sensitivity analysis option. Go to Model Analysis Tools in the navigation pane and select Sensitivity Analysis. Then click New and a new sensitivity analysis will be open. Let's type it as CSTR. There are three tabs which require input data. First one is the Vary tab, which is for the independent variable in x-axis for our graph. So in volume conversion graph, volume should be taken as x-axis for Vary tab. Click New, then variable 1 will open. Then select block variables and select volume of the reactor. The unit is in liters. We can enter lower value and upper value, which is the range for the x-axis of the graph. We can enter 5 as the increment in x-axis. Next, we will go to Define tab. The Define tab is the defined variable in y-axis of our graph. Conversion should be taken as y-axis in Define tab. It is because conversion is an output results in Aspen Plus, and we can define the variable as x by clicking New. Then we select the streams, select the mole fraction of trans-2-butene in the product stream, so that the mole fraction of trans-2-butene, which represents the conversion, will be shown in y-axis of our graph. Next, we will go to Tabulate and click Fill Variables. We can run the simulation by clicking Next button. Then click on SCSTR and click on Result Curve and click OK, so that we can see the volume conversion graph has been generated. We can get at 0.95 conversion, the volume is almost 125 liters. So from this graph, we can get to know the relationship between conversion and volume. Next, we will do the sensitivity analysis for PFR. Before generating the sensitivity analysis curve, we have to deactivate the design spec we generated earlier. So right click on design spec and click deactivate. Then go to PFR setup. We can see that earlier we specified some value for reactor length and diameter for initial calculation in Aspen Plus. So in sensitivity analysis also, we have to generate the length conversion graph instead of volume conversion graph. Go back to sensitivity analysis in model analysis tools and click a new sensitivity. We can rename this as SPFR, and we can enter the reactor length in the Vary tab. So click New, then select block variables. We can see that the volume is not available as a function. However, we can find out the length of reactor. So we select length of reactor. Unit is in meters, so we can enter the lower and upper bounds as 0.01 meters, that means 1 centimeter, to 5 meters. The increment we can specify as 0.05 meters, that means every 5 centimeters. Then go to define tab and we can define the mole fraction of trans 2-butene in product stream as we did previously. Then click tabulate and click variables. So our simulation is ready for running. So click next and run the simulation. You can see no errors. Click on SPFR and click results curve and click OK. Length conversion graph is displayed. At 0.95 conversion, you can see the length of the reactor is nearly 0.3 meters. We can take it as 0.28 meters. Next, we will compare these simulation results with manual calculations. For CSTR, analytical solution using manual calculations gives us at 0.95 conversion. The volume of CSTR is 125 liters. When we consider the analytical solution for PFR using manual calculations, at 0.95 conversion, volume of PFR is nearly 19.732 liters. So that we can conclude simulation results are almost equal to calculation results. We can summarize what we learned in this lesson as follows. Simulations in Aspen Plus software help to model CSTR and PFR with reaction rate law. Sensitivity analysis in Aspen Plus software can be used for analysis of reactor design problems. Please watch our next video lesson about simple distillation column design using Aspen Plus software. Until we meet with our next lesson, have a nice day and goodbye.